about HTML5, giving sort of a status update of what's going on, as well as some lessons learned from the Chrome team that I hope will also help you to understand what's happening in the HTML5 world, things that we're excited by, things that I hope you all will be excited by and can use on your sites in the future. So with that, I'd like to kick it off. Again, my name's Fette. I have about an hour's worth of slides in about 40 minutes, so we'll see how this goes. So quick overview of what I want to talk about. I want to first give you a bit of background in terms of what's the point of HTML5, why are we at Google and on the Chrome team so excited about this, what actually is HTML5. You know, in the keynote this morning, Brian joked that he didn't even know what it meant anymore. It's certainly true. I want to talk about what's happened since 2009 in terms of development in the community, and give you some lessons learned from the Chrome team, things that we have found out to be problematic, as well as talk about some new APIs that are being developed as we speak. And finally, sort of wrap up on the thread of what's next. So what's in HTML5, and what's actually the point of all of this? You know, as we look at what's happening on the web in general, we see a lot of applications moving online. You know, you can look back to Google Maps and Gmail as an example of the beginning of this trend, when things that were traditionally desktop applications became web applications. And as this migration happens, we need to make sure that the capabilities that desktop applications have are available to web applications. If you're going to take a desktop application and move it online, it's not acceptable to say, well, half of the functionality of the desktop version is not going to be available simply because it's a web app. That's no longer an option. Users expect whatever functionality they have in the desktop application to be available from your web application. So we're working to make sure that there is feature parity between what you can do in a desktop application and what you can do on a web application. That's really our goal for this, is to give you the capability that you need to move use cases that were formerly desktop use cases onto the web. So what's in HTML5? Well, even as early as 2008, it was already becoming a buzzword. HTML5 itself was a specification. There was a specification called HTML5, and so you could neatly look at all the features in HTML5. But since then, for convenience reasons, a lot of features have been dropped from the HTML5 specification and moved into their own specification in their own working groups. So things like the storage specifications, the database API, the index database API, file system, these are now in different working groups and different specifications, mainly so that the people who are actually working on these specifications can track the development and work in sort of a smaller group with less noise. It doesn't mean that just because they're not in the main HTML5 specification that they're not, you know, standard, that people don't care about them. It's more of a convenience thing. So, you know, the general overview of that is, you know, don't worry what specification a particular feature is in or what working group is working on it. It really doesn't matter. Browsers are involved in multiple working groups, multiple standards process. The key thing that matters is whether or not there is some working group working on this feature and whether the browsers are implementing it. And for the things that matter, things like offline geolocation, file system, we're seeing that happen. So what are we excited by in the Chrome team? What areas are we looking to for development on the web? We've spent a lot of time over the past years working online. For us, this started with Google Gears. We had Gears as a plugin for Internet Explorer, Firefox, Safari, and this gave you the capability to take a web application and make it work offline. And we did this with Gmail, but this was a proprietary approach. This was us trying something out and seeing what works and what doesn't work. Now we're working on a standard approach. It's called App Cache. This is a way for you to take your application and make it work offline. So I'm going to talk a bit about some of the problems there that we're finding. We've spent a lot of time on media over the past year. You know, we believe that video is fundamentally important to the web. It's trivial to insert an image into your web page. It's as simple as image source equals. We believe it should be as simple to insert video on your web page as it is to insert an image on your web page. Networking. We're seeing web applications using communications back and forth between the client and the server that are very inefficient. You get these giant JSON encoded structures that are being sent using an HTTP post that has a ton of headers. So you send, one character or one word or one sentence, and all of a sudden it's a kilobyte because of all the cruft. We're working on improving this situation such that small communications back and forth are efficient. And we're doing this with a specification called WebSockets. We're also working on CSS3 and paged media so that you can have print layout that actually works as well as or better than online layout. So that if you want to specify, for instance, page breaks or page margins, this will now work. And we're working on platform integration, things like drag and drop, notifications, and geolocation as ways of giving the web platform access to capabilities that are available on the desktop platform. So again, the focus here is providing rich experiences for web applications. So I want to talk about a few lessons that we've learned over the past year, some problem areas. One of the things is offline apps. We've been doing this for years. You'd think that by now we would have this problem solved. But the reality is that there are still a number of challenges that face successful deployment of offline applications. The first is that it's hard to discover these applications. It's hard to find that this application can be used offline. But secondly, it's hard to rediscover them. Once you find an offline application, how do you know how to get back to it? How to launch it again? On things like phones, this is trivial. You have a shortcut in your list of applications or on your desktop. Each phone does it slightly differently, but there's some way where you go to find the applications that you use. On the web, it's harder. If you're just using the application, the app cache spec, it assumes the user goes back to some URL that is the entry point for your application. But how does the user actually remember to type in that URL when they're offline? You could say, well, maybe they use a bookmark. But we have statistics, and I think it's something like only 10% of users actually actively use bookmarks. So bookmarks turn out not to be the be-all, end-all solution for rediscovery of offline web apps. So one of the things that we're working on is what we call the Chrome Web Store. And the Chrome Web Store helps both the discovery and the rediscovery problems. The Chrome Web Store will help users discover applications and learn what applications can be used offline. But more importantly, in my opinion, is that it helps the rediscovery problem because we'll be integrating with a new tab page on Chrome and showing you what apps you have installed. So if you've installed an offline application, be that your mail application, a newspaper, or some application that you come up with, a user who's installed that will see it on the new tab page and be able to just click on it to launch it. So it's more discoverable, more exposed than bookmarks. The user doesn't have to remember exactly what URL to type offline. So we think this is going to be a big advance. And also, one of the things that we notice with offline applications is that the user usually has to approve a bunch of permissions. An offline web application, like an offline email program, wants to not only run offline, it wants to store data for use offline. And most browsers are setting a quota somewhere around 5 megabytes, 10 megabytes of data that's available for you, the web author, to use. But what if you want to store all the email? What if that's 1 gigabyte or 30 gigabytes? You have to somehow get permission from the user to do this. What if you want to use notification or geolocation? These are additional permission dialogues that are going to be presented to the user. And by bundling up something as a web application, we're able to let you specify the permissions that you want to use up front so that the user simply says, yes, I want to use this application. There's a single trust decision that's being made. They don't have to answer 50 different dialogues and figure out how to give you all the permissions that you need one at a time, potentially at different points in time. The next lesson that we've learned is around storage. We started out in Google Gears, at least, with a SQLite database. So, this has pros and cons. A lot of web developers are familiar with SQL. They use it server side, but on the desktop, it's got a few problems. The first of which is that as a proprietary plugin, it's fine, but as something that you're trying to propose as a standard, there's some problems that exist. Namely, SQL as implemented is not well specified. There is a SQL specification, but every single implementation, be that MySQL, Postgres, SQLite, Microsoft SQL Server, Oracle, they all have slightly different extensions and syntaxes that they use, such that it's not well specified in terms of there being a dialect of SQL that is universally implementable by everyone. So in Chrome, when we added a SQLite database API, we used SQLite. Safari did the exact same thing. They did the same thing on iPhone and on Android. But Mozilla and others have said, well, hold on. What if you actually want to use something other than SQLite? How do you implement this API? Do you have to use the exact same dialect that SQLite uses? Do you force the developer to know about all the different dialects? What about when you upgrade? How many people in this room have ever upgraded from MySQL 3 to MySQL 4? Or a Postgres upgrade or any other database upgrade? You know that things typically don't always go as planned. Things break. Queries that used to be fast are now slow. Maybe your schema is no longer valid because something has changed. So when we do this in the browser, the user updates the browser. It's not the web developer who's updating the browser. So what if we update to a newer database implementation? If that causes things to break, that's not going to be good. So we need to have a standard database implementation. So there's a new specification called the Index Database API that a lot of people, ourselves included, are excited about. And this is it's sort of similar to ISAM databases for those of you with a database background. For those of you without a database background, what you basically get are key value pairs. So there's only one index. You don't create multiple indexes and all sorts of strange convoluted queries to do joins. What you get is each table has a single index on a key, and if you want to do any joins, any complex queries, you basically do that in application logic. So the database API itself gives you the ability to look up a key or to get all rows that match some key, and then if you want to do any further processing on that query, you do that in JavaScript in your application logic. So this is a very simple database API that we can actually specify and everyone can implement, but it will also let you do efficient queries. So we're hoping that developers will actually build libraries on top of this so that you don't have to worry about all the complexities of the API. Rather, you can have sort of an abstraction layer, much like PHP and other server-side languages have abstractions for different database layers. We expect the abstractions will be built on top of this database layer as well. But this is a database layer that's actually simple enough and performant enough to be standard and cross-browser. The other thing we've learned is that people want to store files. Whether it's email attachments or photos that the user is uploading to a photo sharing website, we often deal with files. So we're adding a file system API into Chrome, and we're standardizing this in W3C. So what this will provide you is a sandboxed file system on the user's computer. So you can store your data not just in a database in terms of records and rows, but if your data makes more sense as a file, something like a photo that a user is uploading, or even if you're writing an email program, there are a number of ways to store emails and files, be that the maildir format or the mbox format. Developers often want to deal with files, so we're giving you a file system. So you will have a file system that is specific to your origin, so you're not going to be colliding with another website. You don't have to worry about, is another website going to read my files or overwrite my files? It's like a little CH-rooted sandbox for your origin. And you can create new files, you can read files in it, you can, if you're familiar with the Linux file API, it's sort of similar. You have the same types of operations, seeking, reading, writing. So you can do whatever you need to do with a file system now in the browser. This is coming shortly in Chrome. And geolocation, we're seeing a ton of location-based services and location-aware services. You know, one of the first things I did when I got to Tel Aviv is I popped open my phone and I opened up Foursquare so I could check in at the airport. We want this to be available to mobile websites as well. So this was actually one of the first HTML5 APIs to pop up in the Android mobile browser. It's also in Chrome as well. The geolocation API lets you get the user's location as a latitude, longitude pair, and you can also track the user's location. So if they're moving, you can provide updates if that's something that makes sense for your application. It turns out that this was a difficult API for us to implement, which is why the subtitle for this slide is Security UI is Hard. The specification just says you ask the user for permission and you store that for the origin. It sounds really simple, so when Android did this, they popped up a little box that said, you know, maps.google.com wants your location, is this okay? But especially on desktop websites, we see a lot more complex web pages that have resources from multiple origins. These could be ads, it could be maps gadgets on other pages. So if you're on a page and your browser asks, do you want to give this page access to your location? What does that mean to a user? Does that mean that an ad on that page could get your location? Does it mean that if I give maps.google.com access and now I go to some other website like Yelp or any other website that uses a map widget, is my location available on that website as well? And we did a lot of thinking, and from a user's perspective, what we believe is that users think not about origins and embedded resources from other origins and iframes. They think about, you know, I'm on this page, what's happening on this page? So what we did in Chrome is we separated out the notion of the top level page and embedded resources. So if you're in Chrome and you get something on the page wants to access your location, the permissions are actually separate for the top level page and embedded resources. And if you grant access to an embedded resource, it doesn't necessarily follow you around. So if you embed maps.google.com on site A and the user grants permission, that permission is for maps.google.com embedded on site A. If the user goes to site B, that permission doesn't carry over because this is now a new pairing, so they'll be asked again. So for us, this was sort of a lesson in terms of we need to be really careful when we're designing new APIs and new user experiences that we can actually ask permission questions in a way that the user understands. You know, a lot of times as developers, if we want to do something scary, we sort of fall back and say, well, we'll just ask the user. But we need to make sure that the user can actually understand what's being asked and that what's being asked meets the expectations of the user so that they're not surprised on the consequences of whatever actions they take. So in terms of new things that we're working on this year, one of the things we're working on is shared state. If you look at desktop applications, some applications are just a single window with a single instance, but you often have applications that have multiple windows that are sharing some state. So I'm in PowerPoint right now. There's another PowerPoint slideshow somewhere hidden that someone else was using. There's not multiple instances of PowerPoint running and multiple copies of all the code running. Instead, there's one instance of PowerPoint that has a lot of the shared state, a lot of the application logic, and then there's a few windows that are communicating with that same shared state, that same shared context. So we want to enable that same paradigm for web applications that has been available to desktop applications for years. So there's two ways that we're doing this. One is with something that we call shared workers. And a worker is a very simple interface. A shared worker gives you basically a message passing interface. So anything that you can serialize and pass as a message, you can pass into a shared worker. It does not give you, for instance, things like a scripting context that you can share. You can't pass around parts of the DOM through a shared worker. We want to be careful to avoid complex situations like deadlock. So a shared worker is really meant to be a simple shared state that you pass messages in and out from. So what would you use this for instance? Well, I said earlier that we're providing access to a file system. How many of you have ever used file systems in desktop programming before? I see a few. One of the things that you'll know is that you have to worry about race conditions and serial access to files if you are using a multi-process application. And one of the things about the web is that you never really know how many times your application is going to be loaded by a user. The user could have your web application open in multiple tabs. You don't really know what's going on. So much like the default file system implementation on Windows and Linux doesn't do a great job with serialization, the API that we're exposing to the web doesn't really handle serialization and concurrent access either. It's up to you, the developer, to make sure that you don't have any race conditions or any concurrent accesses. So how do you do that? Well, one of the ways is to use shared state. So you can have something like a shared worker that is conceptually controlling all access to the file system. And this is how you can, for instance, make sure that two instances of your web application aren't trying to read from or write to a particular file at the same time. And if they are, you can use the shared worker to make sure that that access is properly serialized and you don't have race conditions. So shared workers have good use for things that can be expressed in terms of message passing, coordination type things. But there's other use cases for shared state as well. So I mentioned PowerPoint as an example, where you have an application logic that you only really need to run once, then you have multiple views open. Gmail had a similar desire. Gmail wanted to say, you know, we've got a ton of JavaScript that runs. It's very expensive to load up our application, and there's a lot of memory use. But users might have more than one Gmail tab open. They might have their inbox open 5 times. They might have a compose window that they've torn off into a little pop-up. And so we want to be able to share state between all those windows. So our team is working on something that we've sort of dubbed Magic iframe. Hopefully at some point in time it'll gain a better name. But conceptually, it's a shared scripting context that all the pages on your origin can access. So what we're doing with Gmail is we're going to take a single application instance that'll host all the logic, all the code, and whenever we create any new windows, be that a second Gmail window or a compose window that's torn off, we're actually going to create most of that window in the main Gmail shared context. And then we're going to do what we call a tear-off, where we basically take the DOM that's constructed and rip it out of the main application DOM, hand it off to the new child page DOM so that we don't have to reconstruct everything. So this will help with startup, but it also provides a few other benefits. Namely, right now, if you're in Gmail, if you close the main window and you've got a compose window open, you're basically out of luck because your main application has gone away. This compose window is now floating and it's useless. With Magic iframe, or this shared state, we can actually keep all that application running in this, the application logic running in this shared state, in this Magic iframe, such that any child windows that get opened up, like a compose window, can actually survive their parent closing. Another thing we found to be important is dealing with files coming off of the hard drive, like the desktop. You know, when I attach files in Outlook, it's very easy because I can just take a file on my desktop and I can drag it on to the compose window in Outlook, and that file is attached. Well, we said, hey, that's a cool use case. We want to enable that for web applications. And so I want to break out of PowerPoint for a second and actually show you how we've enabled this for the web. So if I go to Gmail, what we have enabled is we've enabled both dragging in and dragging out of files. So if I hit compose, you'll see right here, I can click as normal to attach a file and browse for it on the file system, but this is slow and cumbersome. The file I want to attach is right on the desktop. So I'm going to resize this window down a little bit. And I've got this picture of some cute kittens on the desktop, and I really want to email this to Alex Russell, who is out in the audience and about to give the next talk. So what I can do now is I can actually drag this file in, and it's going to be attached. And this is really cool. This is something that's been available on the desktop forever, but it's just now available to web applications. But maybe I don't want to just attach the file. Maybe I actually want to insert it into my message in line. I can also drag this into the message area, and after a short delay, now I have kittens in my email. So this is cool. We have drag in. We also have drag out. So any link, any attachment, I can also take and drag onto the desktop. Ooh, that didn't work. I think it has to actually be an attachment in a sent message. So I will skip that short part of the demo, but you can also drag files from the browser out onto the desktop. So both dragging in, dragging out, important use cases that we want to support. How does this work? Well, you get a data transfer object that has a download URL that you can actually specify such that when you do a drag out from the browser, Chrome is able to take that download URL and know what file to actually download to the desktop. It's for drag out. For drag in, you get a file object that you can then do multiple things with. You can get the contents of the file as a blob and display that in something like a canvas, or you can take that file and, for instance, send it up to the server using XHR. So you've got multiple options for things that you can do with files being dragged onto your application. You can also handle multiple files being dragged. There you get a file list object from which you can get multiple file handles. Notifications, also a cool use case. In Calendar, we've supported a very primitive notification for a long time where we basically do a window.alert to tell you that you have a meeting coming up. This, to me, has been one of the most frustrating user experiences of all Google products of all times, because I'm constantly in another tab typing an email, and Calendar will pop up saying, hey, you've got a meeting, and I've just lost keystrokes, I've lost context because I've had a tab switch, and I can't even find the tab I was on before. So, there's a lot of good use cases for wanting to tell something to the user, but up to now it's been very difficult to do this in an unobtrusive, unobnoxious way. So we've introduced something called a notification API that will let you notify the user something is happening. And this API has two forms. One is a text version, and the other is an HTML version. So you can provide either just a text string or an HTML string that could contain something like options for instance, snoozing the reminder for 5 minutes. Because it's HTML, you can have a little form in there with some action. So conceptually, we want applications to be able to notify the user that something's happening and let the user do something useful in response. So the notification will show up on Windows. It just shows up in the lower right. On Mac and Linux, there's a similar UI. Same concept overall. So what's over the horizon? What's coming next in the browser world? One of the things that our London team is doing, not too far away, is working on both text-to-speech as well as voice recognition. So when I get in my car today, I can push a button and command my car to direct me to the office. And the car will speak back to me things like turn left, make a legal U-turn when possible. Some of these instructions are more sensical than others. But the lesson here is that voice is an important means of communication. And up until now, that's been unavailable for web pages and web applications. So what if you wanted to take a maps program or anything that provides directions and do that as a mobile web page? How do you do that? Well, we're adding APIs for text-to-speech and voice recognition so that you can do that. Voice recognition will take the form of an input tag. So I think the syntax is actually changing slightly right now, but the basic concept is that you have an input tag that can fall back to a text input field if the user agent doesn't support it. But if the user agent does support voice recognition, what the user will see is something like a text box with a little microphone button. The user clicks the microphone button, and then they can start speaking, and we will transcribe the speech for you. So what you'll get is you'll still have a value that you can read the voice transcript from, but you'll also get events like on-change events, and you have the ability to specify things like grammars. So if you know you're expecting a restricted set of inputs, like you just want, you have a direction application and you want to specify that your grammar includes specific phrases like find or go to, you can specify that in a grammar so that the voice recognition can be more accurate. For text-to-speech, we're adding a TTS tag that will inherit from the audio controls. So you'll still have all the controls like play, pause, stop, and start that you would have for any media control, but you don't have to actually generate the media file yourself. You can simply include the text that you want to be read out to the user, put that in a TTS tag, and then when the TTS is played, either programmatically or by the user, whatever text you provided will be converted to speech that's read out to the user. So text-to-speech and voice recognition is great, but sometimes you want access to the raw data. Maybe you want to actually record what the user is saying so that you can, for instance, record someone singing a song and upload that to YouTube. Maybe you want to provide something like a video or audio chat service. You need access to the microphone in a raw form, not just the textual transcript. So we're adding these capabilities as well. We're adding the capability to access the microphone and the web camera, because most phones these days certainly have these two devices, but increasingly laptops and even desktops are coming with these devices. So it makes sense to expose these devices to web applications. Positional audio is something that's also been available to desktop application for years. And this is especially important in things like games. If you get shot at in Quake, you want to know who's shooting me and where are they coming from so I can shoot back. With positional audio, if you actually have a surround sound audio system or even some headphones that are capable of doing positional audio, this is possible in desktop applications with things like DirectX, which provides positional audio APIs. We want to do the same thing for web applications so that games on the web can provide that same immersive experience that games on the desktop have been able to provide for years. So we're adding JavaScript APIs that will give you enhanced audio functionality. It'll give you control over things like reverb, positioning, distance attenuation curves, pitch, all of the things that a normal desktop audio API would provide, we're going to provide to the web, so that you don't have to do all these computations manually. And if you think about what else do games use, well, games typically have awesome graphics. They have 3D graphics, they have immersive scenes. We want to provide that capability to the web as well. So we're adding an API called WebGL, which is essentially JavaScript bindings for WebGL. So for those of you who have seen O3D in the past, this is a slightly different approach. O3D let you build up a scene that was then retained, and you could make changes to the scene. So you could say something like rotate teapot. WebGL is an immediate mode API, so you're constantly issuing commands to redraw whatever you want on the screen. So it is a bit different, but the plus side here is that OpenGL is something that's very familiar to 3D graphics developers. There's lots of libraries for dealing with OpenGL, and we've already seen a bunch of great examples that are provided on top of WebGL. So we're very hopeful that this will enable the same sorts of immersive 3D gaming experiences that you see on the desktop to to happen on the web. So with that, I'd like to save some time at the end for questions. I hope you all have some. Please, there's mics in the middle, or just feel free to shout one out. Thank you very much. Anyone have any questions?
Hi there.
Hey.
My question is, you've shown some really great technologies here in terms of HTML5 and all that, but how relevant is this to Firefox, Explorer 9, other WebKits, Opera, and stuff like that? How compatible are all these technologies?
Yep. So most of the things that work in Chrome will also work in Safari, since we're implementing them in WebKit. Or if they don't work in Safari now, they will shortly as soon as a new version is released. But Firefox and Opera are also implementing a lot of these APIs. So things like shared workers are common and well supported. Things like the file API for drag in and drag out. Mozilla is actually one of the editors on that spec. So a lot of these are gaining good support across multiple browsers. With the new stuff, someone always has to go first. So for things like text-to-speech, voice recognition, there might be a period of time where only one browser supports that. But we're working very closely with all the browsers to make sure that people are comfortable with the APIs, that they don't have any major objections or philosophical objections. So I'm pretty confident that everything will be supported by all browsers in time. There might be a bit of lag, and there might be some, we all have finite resources in terms of who's actually implementing this. So we sort of pick and choose what we think are the most important use cases. But one of the things to remember is that you, the developers, actually have a huge seat in determining what gets implemented. Because if some browser, be it Chrome, Firefox, Opera, doesn't matter which, if some browser puts out an API and people actually start using it, and they show what can be done with it, they demonstrate the cool use cases and the power and the utility of that API, all the other browsers recognize that and basically get off their butt and hurry up to implement it. So you all are actually in the driver's seat much more than we are. If you see something useful, something cool, by all means, go ahead and use it, even if it's only for a part of your population that can use it initially. As soon as you start using it, the browsers are definitely going to follow your lead. So definitely take initiative. Don't wait for everyone to catch up. Lead by example, and browsers will follow. And for those browsers that don't follow as fast as you want, there's Google Chrome Frame, which Alex Russell is about to talk to next. So with that, I'd like to thank everyone very much and invite my colleague Alex Russell up to talk about Google Chrome Frame. Thanks.